piecewise functions today. Piecewise functions are a type of function that are special. So last week we looked at linear regression. We focused a lot on lines. We made the connection between lines and writing equations of lines. Now we are going to look at taking multiple lines and grouping them together. So we're going to take the idea that we can take multiple sets of lines and group them together. So we are in section 6 of chapter 2. We're looking at special functions. Today, our objective is to graph piecewise functions. So in order to graph them, you really need to know what they are. A piecewise function is a function that is defined using 2 or more expressions. They apply different rules for different domains. The x value where the function breaks is called its breaking point or transition point. The point where a function changes is called its breaking point or transition point. Okay, so then we can graph piecewise defined functions with the idea of a breaking point in mind. Okay, everybody good? Okay, that's okay. Awesome. You're welcome. So again, the idea is that if x is less than 1, that's like an open circle shaded to the left. If something is greater than equal to 1, it's a closed circle shaded to the right. Well, we're going to take this idea of the open circle shaded left and the closed circle shaded right, and we're going to take those ideas and we're going to put them on a two-dimensional graph, applying slopes and y-intercepts. So we're going to take this idea of an open circle and a line to the left and give it a slope and y-intercept. So we're going to graph this function using that idea. So we know that the graph has a breaking point at 1. So what that means is the graph changes functions at x equals 1. So some of the x values less than 1 come from this top equation right here. So the idea is that if x is 1 or less than 1, then it's going to apply the rule 1/2 x plus 3. So we're going to plug those numbers in to that equation. So when x is -1, y is 2.5. When x is 0, y is 3. When x is 1, y is 3.5. But we know that x is not actually 1. X is close to 1. So when I graph it, just like x less than 1 graphed with an open circle on a number line, I'm going to graph this point with an open circle and then an arrow to the left. So on my graph, I'm going to plot the point 1, 3.5 with an open circle at 3.5. And then I'm just going to use the idea of slope. So it's down 1 over 2, down 1 over 2. Or it's like saying up 1, right 2, up 1, right 2. So there is that first part of my graph. So the blue part has an open circle at 1, 3.5. It's applying a slope of 1.5 x plus 3. So it goes through the y-intercept 3. Then at x equals 1, we change equations. We now are graphing a new line at x equals 1. We're going to graph -x plus 3. So now you're going to plug 1 in to -x plus 3. Then you're going to plug 2 in. Then you're going to plug 3 in. But because this graph is greater than or equal to, if something's greater than or equal to, it's a closed circle. So when I plot the point 1, 2, I'm plotting a closed circle. Okay? So then the question becomes, what is the domain? So the domain comes from the x values. So if you look here, x is less than 1 and x is greater than or equal to 1. Does that mean that every x value has a number? If x is less than 1 and greater than or equal to 1, does that not mean that every x has a value? Yes, no, maybe so, we agree, disagree, have no idea what I'm talking about. Yes. What is the domain of this graph? So if you look at the graph or you look at the x values, does every x value have a y value or a number? Yes. If every x value or y value has a number, then the domain is, yes. That's okay. I just want you to think a little on your own. I'm trying not to give you every answer. Let's look at the graph for the y values. Does every y value have an answer? Is there a value for y equal 8? No, right? Nothing lives. Are there any y values up here at all? No. What is the highest y value? Excellent. The highest y value is 3.5. Does y actually equal 3.5 though? Is the circle open or closed? Open. So what that means is my range are all the y values less than and really, really close to 3.5. Sorry, I was trying to move it up so you guys in the back could see that. Of course, I'm not going to just do one example and expect you to know how to do all of these. Let's look at another example. All right, we have, once again, two equations. Looking at that equation, ignoring everything below it on the page, just looking at the equation up on the board, where is the breaking point? Perfect. The breaking point is at 2. That means in my table, I need to include the number 2 twice. Do you see how I include the number 2 twice? Wherever your breaking point is, you include that number in the table twice. Which equation, top or bottom, do I use for x values that would be less than 2? So like 0, 1, etc. Good, Colton. Perfect. Negative x plus 4. So the bottom equation. So to help with like color and matching, I'm going to circle that in red. And I'm going to use red to give my answers. Negative 0 plus 4 is? Good. Negative 1 plus 4. Negative 2 plus 4. Perfect. Is the point 2, 2 open or closed? Does x less than 2 include that point or not include it? It's open. Let's plot some points. So you're going to plot the point 0, 4, Jordan, I don't know why that scared you. Did you say oh no? Who said oh no? Oh, sorry. It echoed that way. So we have 0, 4, 1, 3, and an open point at 2, 2. Do you like that nice open circle? Arrow up into this direction. The iPad is not my friend today. X plus 2 for X values greater than or equal to 2. Does that mean at the point over here in my table, is it going to be open or closed this time? Closed. Awesome. I don't know who said that, but awesome. Plug in the point 2. What's 2 plus 2? 3 plus 2? 4 plus 2? No? Okay. Plot your points. All right. Let's talk about the domain and range. Is every X value going to get an answer? Can I plug a number into X into one of those two equations and get an answer? Yes. Therefore, my domain is all reals. Okay, the range. No. Are there Y values that are negative? Are the Y values going to have answers if they are positive? No. What's the lowest Y value on that graph? Excellent. So my range is going to get really, really close to 2. Does it equal 2? Is the point at 2 open or closed? Open. Therefore, it does not equal 2. So your range is Y greater than 2. Okay, tangent question. Is this a function? Oh, we're kind of split 50-50. Somebody tell me why no or why yes. Okay, Nick, what do you think? It would fail the vertical line test, is that what you said? Okay, so yeah, in order to be a function, it needs to pass the vertical line test. Tell me why you think it fails. Yeah, you're the one who said it passed. Why is it or it fails? Why does it fail? Okay, so you have the right idea, but your answer is actually incorrect. Isabella, why? What do you think? Exactly. So, Nick, you had the definition. You knew everything you needed to know. But the actual answer is this is a function because there's an open and a closed circle, and it would pass because the open circle doesn't count. So you knew it. You just flip-flopped the concept. Does that make sense to anybody that thought it was a no? Have I made you believe why it's a yes? So yes, this is a function. Yes, this is a function. Okay, one last example. How many breaking points does this graph have? 2 breaking points. Somebody said it. Excellent. There are 2 breaking points at 2 and -2. So in my table, I need to have double breaking points. So double -2s and double +2s. Okay. Which equation, top, middle, bottom, goes with x values less than -2? Which equation am I going to use for the top part of my table? Nick? Excellent. So is that the top equation, the middle equation, or the bottom? Okay, the middle equation is actually going to be in the middle of my table. X is less than right here. So this less than symbol tells me I use the less than or equal to numbers. So what's a negative and negative? Positive. So negative and -4 turns to a +4. 4 plus 1 is? A negative and -3 plus 1 becomes? Because I was waiting for somebody to say. A negative and -2 is a? So -4, 5 is a point. -3, 4 is a point. Is the point -2, 3 open or closed? Closed. Excellent. Me too. All right. The middle. And I really wish I had purple so I could do purple, red, and blue because red and blue make purple, but I don't have purple in Zoom. So it's going to be green. What? Okay, because blue and yellow make green. I like it. All right. So for x values between -2 and 2, what is the y value going to be? -3 the whole time. Because there is no what? What variable is missing? X. Excellent. Open or close circle at -2, -3. Closed. Open or close circle at 2, -3. If there is no x, then it is a horizontal line when we graph it. I hope yellow shows up. I'll make it a little thicker. All right. 2, 3, and 4 are going to go into the top equation. 2 minus 1 is? 3 minus 1? And 4 minus 1. Open or closed at 2, 1? What is the domain? Yes. So if you look at the graph, this arrow right here implies that it's all the x values to the left of it. This arrow here tells you it's all the x values that are in the other direction. So those arrows pointing to the sides tell you that it's going to continue forever. And then if you look, this point and this point line up. And then this point and this point line up. So that tells you that the points in the middle are also included.
So, what would you say if, the arrows weren't doing that?
Then it would stop. So then it would be like, if there was closed circles, it'd be -4 to +5. Like the domain would be like the beginning and the end points of the x values. I'll give you an example of it tomorrow. I'll make one just to show you. All right, the range is a little bit tricky. Guys, do any y values exist from here to here? No. So you have to be careful. The y values equal -3. And then they start at 1 because they start at this open circle here. And then because the yellow graph continues up, the y's continue up. So the y's are greater than 1 forever. The blue doesn't even matter in this case because the yellow encompasses the blue. Okay? I'm going to be a kindred soul to you tonight. You do not have to do the homework outside of class. We are going to do it in class tomorrow.